Hi there, this is Alex Kiri. Hi there, this is Alex Kiri. Hi there, this is Alex Kiri. Hi, this is Alex Kiri. In today's video, hi there. In some of the next videos, I'm planning to show how to deploy something to Kubernetes and how to configure it. But before that, I wanted to have something to deploy into a cluster. And while there's a lot of already made options out there, I thought it's much more fun to just pick some simple Java service, Dockerize it, push it to a Docker registry, and then later on deploy it into a cluster. So that's what I basically want to show in this video today. Everything except deploying to a Kubernetes cluster. That will be in a future video. That being said, let's get started. So I prepared here a GitHub organization where I plan to put all the sources for all the examples I'm going to use in my next videos. It's called the learn-alexkiri-com. And the only repository that is here now is one called the cool service. And this is basically the service I borrowed from the Drop Wizard project, and I Dockerized. Let's have a look. This project is basically an almost identical copy of the official Drop Wizard example project. And if you don't know, Drop Wizard is a Java framework for developing RESTful web services. It doesn't matter that much. I chose Drop Wizard because I'm familiar with it, and it was easier for me to use it. It doesn't matter so much for what we're going to do in this video and the following ones. But anyway, they have here an example project built with this framework, and it's basically a very basic REST API that has a couple of API resources. I think one of them is called people. So very simple. It's a Java application, and I basically took the example from the official repository, copied in another repository in my organization, and I made a few changes to make it easier to get started with it on a Kubernetes cluster. Maybe not something you do for production, at least the changes I made here, but it definitely makes it easier for playing with Kubernetes just for fun, not on a production environment. So the changes that I did to the example project was to first configure it by default to run with in-memory database, and then enable Hibernate, and Hibernate has a setting to automatically generate and update schema definition in the configured database. All of this just to make it super simple to start the service and be able to interact with it immediately. I also removed some of the configuration from the example that it was not really important for us. Right, so this is the project. You'll notice here I already put a Dockerfile here. So this is the Dockerfile that I added to the project to be able to create a Docker image to build and run this project. So let's have a look at that. This is the Dockerfile. And I will not go into details about Docker or the basics for Docker. I just want to show you here what I did. So one of the things that you have to think about when you create a Docker file, you have to think of what kind of architecture you are building the image for. Of course, you can support multiple architectures, or you can just support one, but it's something you have to consider. In my case, I went for the x86-64 image, which is the most common one. And well, there are situations where you might want to run a different architecture. For example, if you're planning to run this Docker image on Raspberry Pis, then you need to make it run also on the REM CPU architecture. In my case, I just went for the most common one. Next thing is you have to think about what base image do you want to use. And this basically is influenced by what kind of operating system you might need and what kind of dependencies you might need to build, test, or run, or whatever you want to do in the image. In my case, this is a Java service, so I need the JDK to build it. The project is using Maven, so I also need that in order to build it. And I need the Java runtime environment also for running the actual project when it gets deployed. So what I did, I searched, I looked at the OpenJDK project and see if they have some already made Docker images that I could base mine on. It's always a very good practice to just trust the developers of the dependencies you might have to build the best image. It's not always the case, but I always feel that is a better bet than me building everything from scratch. So that's why I chose this one. I went for a Debian Slim, so it doesn't get too large, and running Java 11. Now you notice that this Dockerfile has two stages, and Docker multi-stage Dockerfiles have been introduced, I think, somewhere in version 17, I believe. And it allows you to basically split the Dockerfile in multiple stages. Why would this be interesting? Well, generally you need more dependencies in order to build an app than to run it. So as I mentioned, in order to build this service, I need JDK and Maven. But to actually run it, I only need the binary, in this case the jar file, and the runtime environment. And the runtime environment is considerably smaller than the development kit. And also the image will not need Maven because the artifact is already there. So what you do is when we build this Dockerfile, what we'll have is that a sort of an intermediary container is going to be created where the service is being built and packaged into a jar file. And then all the layers of this container are being removed, and we start from scratch from the Java runtime environment, where we copy the jar file, we configure it with the configuration file, which is part of this repo, and finally we run it using that configuration file. We also we also tell Docker that we're going to expose port 8080, which is where this service is running on. So that's how it looks like. It's a very simple Dockerfile. It's basically a very simple service. So in reality, when you do for a larger project, maybe that has been around for a while, when you build a Dockerfile, this is going to be quite bigger and more complicated. Right, so let's build this. Actually played a bit with it in the previous, before the video. So I'm planning to push this image into Docker Hub, which is a private, I have there a private registry on my username, a public registry on my username, where I'm going to push this image, and then I will be able to use it in a Kubernetes cluster. So what I'm going to do first is I'm going to build it, and I will tag it with the name of my registry, and then the repository is going to be called cool service, and this is version 1, so I'm going to tag it with 1. I also want to tell it that I want to build the current folder as the context, so let's add a dot here. Now I already downloaded the JDK and the GRE images, so this should be relatively fast. Here it downloads Maven. I also copied all the files of this project inside of the build Docker image, or the build Docker stage. Maven was downloaded and extracted, and now basically Maven was started and it downloads all the dependencies of this project. Yes, and Maven seems to be downloading the whole internet. But this is not going to last too long. And the project itself, it has a few unit tests and I think some basic integration tests. So after the compilation is done in a second, it will start running those. So basically the unit tests are run as part of the build stage. And one of the things that I'm not a big fan of the multi-stage builds is because when you run this in production, you will most likely want to have a different pipeline for building, a different pipeline for testing, a different pipeline for deploying and running the service into your production environments. So I will, in that case, in my perspective, is simpler to have multiple Docker files for all those pipelines and stages, rather than having everything in one file. But yeah, there's all kind of opinions and discussions about this, as with anything else. Right. So the service has been the service has been built. Jar has been generated, and the final container has been created. Next, what I want to do, let's just see how the service is running. So I'm going to run the container locally here. So I'm going to do a docker run. I'm going to tell it to run detached and mount whatever ports on the host it has. And then I need to specify the image, and that is cool-service version 1. There you go. And we have a container running. Let's see. Perfect. And it has been it has exposed the port 32,771 on my local host. Let's see what we can do with the API. There are a few examples here. So one of the things we can do is we can create a new resource on the API. So there's a /people endpoint in there. So I'm just gonna, hey, I thought I copied it. Yes. And my port is a little bit different. So I'm gonna type here HTTP. And let's make sure you can also see this. Yeah. Localhost, and the port is 32,771, and the endpoint is people. Perfect. So I just created a person, and what we can do is we can just curl the location. So if I take this and just curl it, here I'm gonna get a list of all the people that are currently there. And if I want, I can access just the one that I created right now. Cool. So the service is working as intended. So the next thing to do is to push it, to push the image to the Docker registry. So I'm gonna push it to. I'm already logged in on my Docker Hub registry. So I've already done that before the recording. So I only need to do this. And right. So it's gonna start pushing everything, all the layers that are not already on Docker Hub. Right, and that should be done, I guess. Yes, let's see here. I'm gonna refresh my Docker Hub. And there you go. There is now a new repository here with a new image and the first tag, which is tag 1. So now we can use this and deploy it on a Kubernetes cluster, which is something we're going to look in the next video. So until then, get your clusters ready. Maybe check out my videos. You should see some links here on the screen. I have created 2 videos where I show how to get started with running a multi-node Kubernetes cluster on your local machine using Kubernetes and Docker. So do check those out. You don't have to run them. You don't have to use those, but if you want a cheap and convenient Kubernetes cluster, then I do recommend that. And please let me know in the comments what you think of these videos. If you have any requests on topics to cover, or just, simply want to say hi. So until next time, thank you for watching and take care.